Okay, today we're going to be doing notes for free fall. This is your last part of the notes before your test that's on Thursday. Okay, so up until now we've been dealing with motion in one dimension going horizontally only. So now we're going to be dealing with free fall, which is vertical motion downward. So the acceleration of objects in free fall is given a special symbol G. That stands for gravity, because when anything falls, it's due to the force of gravity acting on it. As you can see up here, these kinematic equations should look very familiar with a slight difference. Now we have y's instead of x's. So we have our vertical final velocity with our vertical initial velocity, vertical acceleration, and then we can now put 9.8 meters per second squared in for that vertical acceleration because it's going to be the acceleration due to gravity. And then this is the position kinematic equation, and instead of having x and x naught, we have y and y naught. So it means the same thing. You have an initial vertical position and a final vertical position, and something falls between the two. It's just instead of x's, you have y's. So any of your kinematic equations that y'all have been using, anytime you see an x, you can substitute it with a y, and that's going to be a vertical value. So we replace x by y for motion for constant acceleration because free fall is along the vertical axis, like I was saying. These equations use the choice that positive y-axis is downward. Remember, that direction is up to you. You can make everything going down positive, or you can make everything going up positive. That's your choice. So because these are making down positive, I have positive 9.8 meters per second squared for my acceleration. But if I made up positive and down negative, I would have negative 9.8 meters per second. And anything going down would have to match whether it's positive or negative. Here are some motion maps and graphs. These should look very familiar to you. Motion map, remember the dots are the time and the arrows represent motion. So this object is going up and then coming back down. Notice it's slowing down as it goes up and speeding up as it goes down. We have this position graph. Notice we have y on the y-axis now because that is the vertical position of the object and it's not the horizontal position anymore. So it starts at 0, it goes up, and then it comes back down. Here we have the velocity of it. It's the vertical velocity because we have Vy on the y-axis. So we have a positive, this one is making up positive and down negative. So it's going up, so it's in a positive position, but it's slowing down, so the slope is going to be negative for that part. Then when it's coming back down, it has a negative velocity. That's why it's down here. And it's speeding up as it comes back down, so the slope is still negative. If your velocity and acceleration are in the same direction, remember it is speeding up. And if they're opposite directions, it's slowing down. Then we have the constant acceleration. It's negative 9.8 because the acceleration of anything that's in the air is 9.8 meters per second squared because of gravity. Now, if I had made up negative and down positive, my 9.8 meters per second squared would be in the positive portion of the graph. So just make sure you choose your positive and negative direction as up and down and stay consistent throughout the entire problem. So we've already talked about how acceleration is 9.8 meters per second squared because of gravity. So anything that is falling in the air is falling because of gravity, so that acceleration is going to be 9.8 meters per second squared. And it's going to be downward. So if down's positive, it's a positive 9.8. If down is negative, it's a negative 9.8. So here's an example. Not yet, just kidding. So we talked about gravity. You can set your positives or negative. Okay, so down positive, down negative, it's up to you as long as you are consistent. So all motion directed downward. So if you assign down as positive or negative, everything in that direction has to match. Anything going down has to be what you say it is. Anything going up has to be the opposite. So here we're choosing to make down positive. So if an object at rest falls and drops 10 meters, how fast will it be moving just before it hits the ground? So first you have to list out your variables. We also drew a picture. So it's asking how fast will it be moving just before it hits the ground. So that's my vertical final velocity is what we're looking for. We know the distance that it falls is 10 meters. I know that it starts at rest, so my initial velocity is going to be 0, and I know my acceleration is 9.8 meters per second squared. Notice my 10 and my 9.8 are both positive. That's because it falls down 10 meters and the acceleration is downward, so both of them are positive based on what I chose up here as my direction downward as positive. I choose the kinematic equation that matches my variables and what I need. So this is the formula I use. Notice all the x's that you see on your formula chart are now y's because I'm dealing with vertical motion. You substitute your numbers in, you get your answer. Don't forget that this formula, the vertical velocity, is squared, so you have to square root it to get your actual answer. And it's going to be 14 meters per second downward. I know that it's downward because I calculated a positive number and my positive is down. If I wanted to make down negative, I would have a negative 10 and a negative 9.8 and it would work out to be the same answer. Okay? That's it for your notes. Make sure you look back over on all of the notes in the worksheets before your test on Thursday.